All right, 3.2, we're going to study two methods for solving systems of linear equations. First thing we're going to study is the substitution method, and then we will study the elimination method. Some of you may have heard that called the addition method. So we'll start with substitution. Here I have an algorithm. Algorithm is just a fancy way of saying a list of steps to follow in order to complete some task. So our algorithm for substitution, where do we start? We will pick one of the equations and one of the variables. We will solve that equation for our chosen variable. Then we're going to take that and substitute it into the other equation for that variable that we have chosen. Make sure you're using parentheses at this point because usually there's some distribution that needs to occur. We don't want to make a mistake and not distribute our multiplication. All right, we will solve that equation for the remaining variable. We'll take that information, we'll back substitute that into any of the original equations and solve for the remaining variables. So we will have solved for one variable, we'll have a value for that. We'll go and plug this into one of the equations and solve for the second one. At that point, we form an ordered pair. This is kind of optional. We can also just list our solutions. And then we'll check to make sure that our proposed solution works in both of the original equations. Okay, so here we have our first example. It says solve the system. We'll solve this using substitution. Substitution first step says pick one of the equations and one of the variables. I'm going to solve that equation for my chosen variable. It doesn't matter which one I choose. I have equation 1 as x plus y equals 5 and equation 2 as 3x plus y equals 7. I'm going to be a little strategic about this because I want to make my life as easy as possible. Over here, notice that x plus y equals 5 is very nice. I don't have any coefficients to worry about, just one in each case. So it'd be very simple for me to solve this either for x or for y. I'm going to choose y because I notice in equation 2, the coefficient here is also a 1, which means I won't need to worry about distributing any multiplication. So to solve this thing for y, that means I want to put it as y equals. I'll just subtract x from both sides. And that's it for step 1. Step 2 says, take this information and substitute it into the other equation. The other equation here is 3x plus y equals 7. Well, if y is equal to 5 minus x, I see a y here. I can just put that in here for y. So I can just write 3x plus, what is y? Well, y is 5 minus x. Since this is just a 1 out in front here, my imaginary one, invisible one, I can in fact just write this out as 3x plus 5 minus x equals 7. I can simplify this a little bit, combining my like terms, 3x minus x, so that's 2x plus 5 is equal to 7. Step 3 says, okay, solve that equation. We now have an equation with a single variable. We know how to solve that. We take this and solve for x. I'll subtract 5 from both sides. That's 2x, 7 minus 5, 2. Finally, divide by 2, and I find that x is 1. Step 4 says back substitute this information into one of these equations. It doesn't matter which one. I know what x is. I need to figure out what y is. I notice this thing right here is already solved for y. So in fact, the smart thing to do, step 4 says, why don't I back substitute this into the thing that's already solved for y? I'll take 5. I know what x is. It's 1 minus 1. This tells me that y seems to be 4. Last thing I'm going to want to do is check, right, for my solution and then check it. So step 5, my proposed solution here is x equals 1, y equals 4. I will check this in my original equation. In fact, both of my original equations. So I'll start with equation number 1. That's that x plus y, I want that to be 5. If I take 1 plus 4, yes, that is 5. Perfect. Second equation said I want 3x plus y to be equal to 7. Well, 3 was 1 and y 4. Well, that's 3 plus 4. So yes, that is indeed 7. 3 plus 4 is 7. So both check. And I am pleased because now I have a solution. Last thing, I'll just indicate that my solution is x equals 1, y equals 4, or equivalently, if you wanted to create an ordered pair, x comes first, y comes second, it's the ordered pair, 1, 4. Next step says, okay, if p equals 3, take that information back and find out what q is. So this is our back substitution step. I have that q is equal to 2 times p minus 8. And we have just discovered that p is 3. That gives me a 6 minus 8, which leads me to believe that q is negative 2. Last thing we want to do is check. All right, so our proposed solution here, we believe that p is equal to 3, q negative 2. Our final step is to go ahead and check this in the original system. So my initial first equation was 4p minus 2q is equal to 16. Let's make sure that if p is 3 and q negative 2, that this does indeed work out. So we'll say 4 times 3 minus 2 times negative 2. We hope to find that to be 16. That's 12. 4 times 3 is 12. Negative negative gives me plus. 2 times 2 gives me 4. And yes, 12 plus 4 is 16. Let's check on the first equation. Let's check the second one. Second equation said 5p plus 7q. I want that to be 1. I take 5 times 3, add 7 times negative 2. I have 15 here. This will be negative, and that's a negative 14. And yes, 15 minus 14 is 1. We're satisfied. Our solution, it is p equals 3, q equals negative 2. And if we wanted to write that as an ordered pair, we just write that in alphabetical order, p before q, so 3, negative 2.